In our last couple of videos, we introduced the concept of an exponential growth or an exponential decay function that can be a model of a real-life process. In this video, we're going to look at how we can find that model by finding the rate, finding the initial amount, if we're given two data sets. So for instance, the city of Farmington, Arkansas had a population of 3,178 people in the year 2000, and it had a population of 4,461 people in the year 2010. And these are both taken from census data. And what we want to do is find an exponential model for the population of Farmington in year T, when T is the number of years past, and we're going to use our initial year, the very first year that we're given. So the year past, the number of years past 2000. So we're always going to use the earliest year that we have data for as the year 0. So in 2000, T equals 0. That's what let T be the number of years past 2000 means. All right, so we're trying to find here an exponential model. That means an exponential function that can predict the population in a given year. So we know that our basic exponential model is P of T, or the population in year T, equals P sub 0, our initial population in year 0, e to the kt. So P of T is the name of the function, the population in year T. P sub 0 equals population in year 0. P of T is the population in year T. K is my rate, and we see that we started with 3,178, and then after some time we had 4,461, which is a larger number. So K is going to be a growth rate in this case. If the numbers were decreasing, it would be a decay rate, and it would be a negative number. And then T is just going to be the number of years past 2000. And remember, E is just the number E. That's part of the formula. And then K and T. All right. We see already given in the problem, we have two amounts. We have 3,178 in the year 2000. What that's saying is that when T equals 0, because T equals 0 in 2000, P of T, or P of 0, is the population in year 0 is 3,178. So P of 0 is our starting amount, is the exact same thing as P sub 0. So that tells me P sub 0 is 3,178. So we have our first piece of our function. P of t equals P sub 0, which in this problem is 3178. E to the kt. So now the 3178 is part of the function. That's not going to change. We're going to use the second pair of numbers that we have right here. The population in 2010 is 4,461. So in the year 2010, we're 10 years past 2000, we have t equals 10. So P of 10 is 4461. So what we're going to do is we're going to say, I'm going to go ahead and rewrite those two here. P of 10 is 4461 when t equals 10. So we can take each of those numbers. P of 10 is 4461. We can put that in place of P of t, of the whole thing, P of t. And then when t is 10, we can put the 10 in for t. And that gives us the equation. 4461 equals 3178 e to the k times 10. And we can solve this for k. We can find the rate, the growth rate that would allow 3,178 to grow to 4,461 in 10 years. Now we know how to solve this equation based on what we've learned in previous lessons. We would divide both sides by 3178. And I want to keep a lot of decimals here. I can either leave it as a fraction or I'm going to put all of my decimal places because I don't want to have rounding error. So I have, that's going to equal 1.403713. That's probably enough places. That divided out the 3178. So I have e to the 10 times k. And now to solve for the variable in the exponent, I'm going to take the natural logarithm of both sides. The natural logarithm of e to a power is equal to that power, the exponent. So now I can divide both sides by 10. And I get that my growth rate is, and I'm going to go ahead and round this to 4 decimal places. Natural logarithm of my previous answer divided by 10. And I'm going to get 0.0339. And then there's a 1 after that. So it stays at 9. And we normally write, if I ask for the rate as a percent, the growth rate, it would be 3.39%. Because remember, you move the decimal to the right 2 places. But what the problem asked me to find was the model. So I'm actually writing an exponential function. P of t equals 3178 e, and now I'm going to put in the k that I just found. And this is my exponential model. So just to recap, we used the first year given as year 0, so that the amount given in that year was P sub 0. And then we use the second data point to plug in for t and p of t and solve for k, our rate. Once we have that exponential formula function, we can use it to, let's say I wanted to predict the population of Farmington using this growth model. In the next census year, 2020. So what this is saying is, what is the population? What is the population equal to given t equals, and 2020 minus the initial year 2000 is 20. So we know that we have the year 2000, the year 20. So this is saying find p of t if we know that t is 20. So all we need to do here is plug 20 into our function using our rate that we're given. And remember, when we plug this in on the calculator, we need to be sure to put parentheses around the whole exponent, not double parentheses. So plugging that in, I have 3178 e to the 0.0339 times 20. And I have approximately equal, and I'm just going to round to the nearest person here, 6,260 people living in Farmington, Arkansas, according to this model.